Thank you. Hello and good afternoon. Thank you for joining for this last session for this conference. My name is Manuel Oloarte Maeder, and I have been working for the past 7 years as a cloud engineer. Currently, I am working as an engineer manager at Erslate, Poland. Today, I'm going to show you a use case from the time I was leading a DevOps team at Erslate for the product called SignNow. I want to show you and highlight you the reasons why SignNow transitioned to dry code, to these dry principles. I want to highlight the advantages and disadvantages of this approach. So let's start. Just something quick about Erslate. Erslate is a product-based company. Our product evolves around automation of document workflow. We edit online, sign and modify documents. We allow our customers to integrate our services within their businesses through our API or through our third-party providers who are already connected with us. And now that the commercials are over, let's start with some background about SignNow and the product I was working with for the past years. So SignNow is a product that's one of the top 10 online solutions in the market right now, depending on which ranking you're reading, right? And we process every month over 1 million of new documents and have around 177 million documents stored. We have recorded also around 300,000 of active users per month on a total registered use base of over 80 million accounts. Now, SignNow, around 7 years ago, was using a monolithic architecture, so the old school style. We had, our core was launching and configuring EC2 instances with the help of SaltStack. For those who don't know what SaltStack is, it's something similar to Ansible, to Chef, or Puppet. And the way we deployed the deployed service to the developers was like creating managed packages in RPM format, uploading those to this RPM repo that we owned, and installing those locally, right? And we understood very well that that type of approach had no futures around that time, since it was everything all around containers and so at the very same time, the engineering and development team was deciding to extracting those services from the monolith and creating and launching them in a containerized architecture. And so it can be that SignNow started to use, of course, the tools like ECR, or like Elastic Container Registry, the Elastic Container Service. And all of this was managed, of course, through Terraform and TerraGrant, in our case. So in the end, after this transition, we were able to record around 45 services. These 45 services were consisting of one application, multiple scheduled tasks, and multiple worker units. In total, we had also an amount of 5 different environments, and this is very crucial because all of those 5 environments were identical to each other. Maybe the only difference were maybe that some services were probably turned off in some environments, or the resources were different, because of course you wouldn't assign the same amount of resources in a development environment like in a production. And what you can see right now is our approach on how we did it at the very beginning with Terraform, and we use this from HashiCorp recommended approach, where you have at the top level domain the directory with the environment name. Then you have this region directory when you open this region directory, you will find that then like the amount of resources that you are configured inside this region. It's kind actually of a mess after a few years, because if you can see, we still can, when you open like this type of directory called services, you will find like a section called backend, and then you will find the amount of services. And here is actually a nice example of what we had for when we were opening one service. We have this dashboard service, and this dashboard service consisted of just this application. There was a configuration directory where you would store the artifacts, maybe the IAM policy, tokens. Then you will see that we have like these terraform files for DNS, for the main, and other stuff. And now imagine this. You have, for this application, this amount of files. Then you have for the worker, maybe around the same amount of files, minus, of course, DNS, because we won't need that. And then you have this for another 45 services, the same amount of files. So this type multiplied by 45, multiplied by 5, because we had 5 environments. It's a crazy amount of data, also an amount of code lines that we were just repeating. So, at some point, I decided to understand what we're going to change. And for this, the first thing that I already knew was that we were having this Terraform 0.11 code base, and a mix of also to 0.14. And there's, of course, this problem that at some point it could become deprecated and not even runnable, which is actually already the case. Then my personal issue was with the pull requests. I get a new service, like someone launches a new service, creates a pull request, bam, 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 files. And then he will do the same pull request for a next environment. So I will have to review the very same thing, which was kind of like a time wasting. And nonetheless, despite of having reviewed the pull request, we found out that we had discrepancies with the service names, discrepancies with the directory names. So while reviewing those pull requests, we have to make absolutely sure that even though it's just like a copy, there might be something inside that changed, and this can affect the dynamic on how the service would work in the end, or the infrastructure for the service will like set up. And one of the last issues that I also understood is our engineering team came to us asking, hey, guys, keep asking us information about our architecture, and I would like to show them our infrastructure code and tell them, hey, just read it. You know, you don't have to waste time with asking us what we already know. But for them, it was confusing. For them, it was like going through all the directories from one environment and then try to repeat the same for the next environment. It's crazy. So right now, I would like to explain to you what were also our motivations on how we went from wasting everyone's time to the dry principles. So I sold this to our upper management like that, hey, we need to clear this technical debt. We really have to clear this. This has so this type of code has no future, and it's a risk to be not runnable. I wanted to create a standard for how we should be launching the things all the time without having to review it again and again and again. And this standard will also help other people to understand how things are set up within our infrastructure as a code. I wanted to improve velocity. Reviewing those pull requests that are the files that are repeating is a waste of time. I want to improve that. I want to improve how we launch services. I want to improve that. I want engineers to be involved with the launching of services. I want to give this platform for them, a platform where they can just contribute to our repository and make changes on their own. And one of the quotes that's very stuck within me was actually came from a solutions architect. Hey, why it's not possible to have a cleaner directory structure? You know, just one code base and just a little files with configuration that is different from environment to environment. And so, if we will have used this like original approach, which is also described by TerraGrant, our repo would have looked like this, like our dashboard service. So we will have for each resource this TerraGrant file. And within this TerraGrant file, there will be you know, a reference to some module, to some template, whatever. And inside there will be like some inputs with parameters, which is all okay. But you know, we will still have this issue with the environments. Again, we will have the same thing. We're repeating ourselves, and dry principles dictates that you should try to avoid repeatable code or repeatable patterns. And so I decided to go this way. It's a way where you will have only one code structure, and inside each resource you will have only this config file, config directory containing these environment files. Okay. So, how does this work? When you work with Kubernetes, you set a context, right, to choose which class you are working with. When you use AWS CLI, you set the profile, which account you want to work with. And what I do is I set an environment variable. And this environment variable is then used by TerraGrant. When TerraGrant runs, it picks up this environment variable, and it's able to resolve all the needed references because it looks up the environment files. So, when we do such a thing like creating one directory, one code base, we have to make sure that some core elementals are configured the proper way. And here are some tips for that. First of all, the data tier directory, which contains providers and modules. These providers like AWS or the null resource or the random. If you don't configure that, it will create the standard .terraform directory. And this will have a problem because there will be a collision because when we run on the same directory for a different environment, they will say, hey, there's a problem because this file already exists or this is the wrong reference. And so we have to configure it that there is another name. It is also very important, and this doesn't matter for this solution. It's this TerraGrant, this cache tier plugin. Because when you run Terraform init and you install the providers, it will download them in your directory you are launching Terraform from. But with this parameter, you will have a centralized location where these providers are installed. Then, while running Terraform init, it will create a symbolic link to this file. So you don't have to download it, which makes things a little bit faster, and it saves space on your location where you are running Terraform or TerraGrant. So we run TerraGrant, and I set the environment name dev. And so TerraGrant will look up, first of all, the dev HCL file and the dev JSON file for really global variables. And then it will look up the resource which I just showed you before, where it looks the directory with the config dev JSON. All right. So now part of the dry approach is also try to generate files yourselves. So we also have a few things that a few templates which are generated while running TerraGround. And I will, of course, show this a little bit later. And the one point is that probably a few people maybe don't know about it, is this TerraGround cache, if you don't use TerraGround. When you have this Terraform block inside this TerraGround HCL file, then TerraGround will download the module to your local directory, and it could you can actually modify it like this, that it doesn't download everything you need, but you will see it very soon, because I would like just to show you a demo on a mock repository that represents actually the same thing that I created for now a few years ago. So we have here, I just want to check, is it normal? It's visible. So we have here this directory, and first of all, for this conference, I created a new AWS account. And of course, if I want to run Terraform or TerraGround the proper way, I would like to have my dev state files not locally, but on an S3 bucket. I won't have to have this DynamoDB table for the log system. I want to have the KMS key created so I can encrypt those things, because I want to do it the right way. And for this, I have this init directory that I use, where I define these resources, like the old way. And since of course there is no such S3 bucket, I just saved the dev state file locally. It's the only time I save dev state files in a repository, just because I'm never going to use this again. You're not going to set up again to reapply this code again once it's done. So it's actually already this. It's part of this dry principle, because here I have. I'm not repeating myself 5 times for the 5 environments, only once with the base code I have, and I only define maybe some tags that can be different from environment to environment. But first things first, why do I have actually this common config with some global variables, right? I actually do have these default tags. I use default tags to make sure that all resources within that environment have these tags. I set the account ID. I could extract the account ID over some data resource, but this is kind of a safe log for me, because if the account ID that I run doesn't match the one is here, then I understood that I'm running my things in the wrong account. I want to avoid that. Here, this is only just inputs that are used by our TerraGround HCL file, which looks actually. I'm not going to go too much into detail. In the TerraGround HCL file, we define here this environment variable where we get extract from our environment variable. Then we defined which remote state, how it's configured, which region, which bucket, and which KMS key it's using. And then I have some extra arguments. Extra arguments are used to limit the amount of arguments that you pass to Terraform depending of what comment you are running. If you run TerraGround output, then it will pass this TEF data dir and this TEF plugin cache dir argument. But if I want to run a plan and apply, it will make the lookups that I just mentioned before to the resource configuration. I don't need lookups of resource configuration when I run Terraform init. So this is a nice way just to route and manage this. Okay. In this example, I have already launched a network in the development account. you can see here that I say I include the root. This means only that it will look up this Terraground HCL file that is located at the top level directory. Then you can see here this include. This is the first file that we generate through automation. The automation that is allowed through Terraground, and it says that, hey, get me the file from the sources providers AWS main HCL, and if we look at it, then we see here this generate block with the path which defines actually the name of the file, which is called generate provider AWS. And I actually set also a global rule in gitignore to not add files that have the prefix generated. And the content is, of course, the thing that we write most of the time: provider, region, profile, default tags, and a few variables that are helping you for running Terraform. So let's get a little bit practical with this for an existing resource, and we will open it in terminal like this. Just to highlight right now, I have, like, for example, also set my console to show me the environment of Terraform I'm working with. So right now there's no environment set, and you can see it's here. And if I set like export, then I will see the value of this environment variable there. So I know actually where I'm actually applying. And if I go to another directory, this variable will disappear because I don't need, for example, on my home directory to see in which environment variable I've located. Yeah. But so just just a second. It's taking a little bit longer than expected. But while we're waiting until this is done, to show you the files that have been created. First of all, this Terraform .terraform file, where the modules are located, has been created, right? Here you can see it has the subdirectory dev, which is something that I defined manually for that, so there is no conflict with other environments. Oh, that's good. It's done. Then here you cannot see it, but if we like, we'll show you like this Terraform dev providers, Azure Corp, AWS, I think it's like, no. Oh yeah. Here you can see that there is a symlink to the file that is actually located inside this .terraform plugin cache registry, which is something that we have here on the top. So we don't actually download that provider anymore. Okay. Now, I mentioned before about this Terraground cache directory. This happens only when you set this Terraform block configuration. And what it does is it downloads, first of all, the module. Then it copies all the files that are located in the location where you run Terraground, and it copies to this inside this location. So here you will find again the same Terraground HCL as a copy. You will find my generated provider AWS file that I just mentioned before. You can see it on the top. that is said generated by Terraground, right? And then it will, and of course my configuration files. So the Terraform will be running on this directory, and it will apply all the things that it found before. If we talk about how easy to perform changes is, then let's take a look, for example, at this like ECR. I just come here and say I have this user acceptance test environment. I just copy this this configuration file, maybe make some small changes depending on what you do, and it actually doesn't really matter. Forgot to. Oh, here it is. And I have to export. I change the environment name to the new environment. Oh, sorry. Wrong location. So. So this is going to run a little bit faster because it says it's found in the cache, and that's it. I mean, I don't have to do anything because I already reviewed the code. I already know what it's going to do, and I only need to apply some configuration. Now, just a little thing about templates and generated files. It is okay, I mean, to use modules when you are referencing to them, because modules have use a version system, right? You can say use this type of module with this type of version, and so if something doesn't go well, you can always change the version. But with templates, like I did here, there is a small risk because there is no version function when you use templates. These templates are, for example, like this ECR directory, because it's for a simple resource like ECR, where I don't need a module really for that. I just need to be able to create like ECR artifacts repositories for a purpose, and I want, for example, to configure a lifecycle, and that's it. I don't need for that a new repo. You could create a mono repo, but I decided against it because there is no real need to do that. So let's go back quickly. Here. For me, it was very satisfactory to see certain changes, because when we applied this solution and we created for that a new repository, we were migrating, for example, the first service with 3,300 lines of code, and we were replacing it by, with 256 lines of code, which is massive. And I mean, it's for 5 environments. We had another service, 1,600 lines of code, replaced by 135 lines of code. For me, this is very satisfactory, like a very satisfactory stats to see. And we had a lot of such services, so over 40 of those. So, why would you do that? What are the advantages of using dry code and in general also this kind of approach? Performing changes has never been so easy, really. Every people, even the ones who have no idea how to use Terraform, they just can go inside the project, look at the configuration, and make changes that are for them very easy to understand. Additionally, the visibility across the environments has been like simplified. You can compare right away what we're running in the development environment, what we're running in the production environment, without searching across the directory structure jungle, which I called. Templating is a very cool way to save time, because when you create templates, you create a standard where you dictate how you want to launch a resource and how you want to configure it. I don't want to see, for example, that someone creates a CDN or a Route 53 record one way, and in another directory it's a little bit another different way. Of course, it's possible, you can read it, but it saves time if you have it everywhere the same way, if it saves the same purpose. READMEs are also very helpful because before, of course, you have one README and you will copy this README across all environments. Also a waste of time. You create only one README, you only update once, you can describe a diagram, how the service is used, and you will understand right away everything. And of course, we, as cloud engineers, started to work differently because right now we put a lot of emphasis on creating code at base that is has to work for all environments. We have to make sure that the code and the syntax within supports multiple environments. When we make a change, we make sure we get, again, we start with the development change and we apply it everywhere until we know that it works. And we don't break production like with code. The disadvantages of this specifically case, which is an edge case, is of course that you have to start from scratch. When creating a new repository and migrating your existing resources, it's going to take a toll on your time, on your nerves, because it's you create new code, you cannot just import like this, and we have to do it a lot of stuff you can do manually. What we used to do is to generate the way the comments, how we are going to import through a Python script, depending on what we have. But it has also a little some plus sides, because when you recreate everything from scratch, you are allowed to see, hey, what did change, which kind of parameters have been appeared, because you will be migrating things that you created maybe 5 years ago, and the AWS provider changed, parameters changed. For example, S3 bucket, at the very beginning there was a big block of configuration. S3 was split in smaller resources. So I used it during the import. I used that and created small resources, and I was able to kill technical debt. And of course, this type of solution is not adoptable in every organization. This is a special case because, as I said before, we have identical environments, and that's why I could pull this off. And one of the biggest downs is when you break a template, when you find a bug in a template and you have to debug it. It's interesting, of course, to do some code debugging, but let's be honest. Terraform is a domain-specific language. It has some limitations. It can look sometimes very dirty, especially if you do like within a for loop and create like your own maps. It can get nasty. It takes a time, but it's fixable. So that's for now. That's it about my directory structure. I would like also to talk about how we apply changes with our Terraform code through the use of Atlantis. Well, just imagine this: you go into the repository, you make a change, create a pull request. You go into GitHub, you already see that Atlantis created a Terraform plan for you. Nice. Now someone else comes, reviews your pull request, accepts it, and then you can just write a comment called Atlantis apply, and your code will be applied. This saves time, this saves permission, because you don't have to set up permission for someone else to access your AWS account, because it is all through the Atlantis. You have your own Terraform runner. You could use GitHub Actions. You could use it. But I better have my dedicated and managed own Atlantis runner rather than the GitHub Actions runner. But be very careful, because Atlantis and running Terraform is a dangerous thing. You have to be very careful. And here are a few security tips for that. Make sure you harden your endpoints. I mean, the Atlantis takes request from GitHub. GitHub sends request to Atlantis whenever there is a push, a commit, or a comment. So make sure that you have like one entry point where it allows only GitHub to connect to this webhook endpoint. At the same time, Atlantis has the possibility to be viewable through the web browser, so you have to secure this as well. Atlantis doesn't provide you an integration with some SAML or Active Directory. You have to put it yourself. You have to put something in front that authenticates you as a user that is allowed to look in what is going on within Atlantis. Running autoplan, it sounds like a nice feature, but it has security concerns in production. If you use, for example, this null resource configuration block, when you run a plan and it will execute an executable defined inside this null resource block, and maybe someone with bad intentions could do something bad with this executable that is running on production. So be careful with that. Try to use code owners. Code owners can make sure that only certain people are allowed to approve your pull requests. Otherwise, if everybody can go around this and apply, it will apply resources or delete resources in your production environment. And for the sake of God, when you use Atlantis and you introduce this to your developers, use labels. Define those labels. Like, hey, this is a pull request that should be used with Atlantis. It is waiting for apply. It has been already applied, and you only have to merge it or something like this. Just that you don't have to go every time inside it and try to figure it out what's going on. So, with this, I'm at the end of my lecture. Please make sure to rate the lecture because it will be very helpful for the organizers as well for me. Thank you very much for being here, and if you have any questions, just ask. Thank you.
Yep, raise your hand.